There are two things we are trying to accomplish in this packet of notes, okay? First of all, our main goal is to construct the unit circle from scratch, okay? To understand what the unit circle is, to understand the angles, both in degrees and radians, that are on the circle and where they're located, and to learn how to come up with the coordinates of each point corresponding to a particular angle on the unit circle. Okay, that is the first main goal of this packet of notes. Okay, the second thing we want to do is to calculate or learn how to find the exact values of the 6 trigonometric functions of all the angles on the unit circle. Okay, and when I'm talking trigonometric functions, I'm talking sine, cosine, tangent, cosecant, secant, and cotangent. Okay, so for every single angle on the unit circle, okay, we are going to learn how to compute those 6 trigonometric functions. Okay, so for example, pi over 6, which is 30 degrees. Okay, that's on the unit circle. Okay, so we're going to talk about how you would find the sine of pi over 6, the cosine of pi over 6, the tangent of pi over 6, and so on. Okay, and we're going to learn how to do this for all the angles on the unit circle. Okay, so on page 5, what you see is a chart that we're going to fill in. Okay, across the top, I have 4 different angle measures. It's the 4 angles we just worked with on page 4. Okay, so I've got pi over 6 or 30 degrees, 5 pi over 6 or 150 degrees, 7 pi over 6 or 210 degrees, and then 11 pi over 6 or 330 degrees. And we're going to go through these and talk about how you would find the 6 trigonometric functions of each of these angles, okay? We're doing it this way because on page 4, we took the unit circle and we came up with the coordinates on the unit circle corresponding to these 4 angles. So if I go back to this page, since we already have it nice and built, we've already looked at these particular angles on the unit circle in detail. For each angle, we have the corresponding right triangle built. It is a great opportunity for you to see how this is connected to the 6 trig functions. So that's why I'm kind of doing this all at once. Okay, so we met the 6 trigonometric functions back in section 4.1 when we studied right triangles. Okay, we learned that these 6 trigonometric functions are basically ratios of the sides of a right triangle. Okay, so to recap what we learned, okay, I'm going to kind of write this out over here. We learned that if you have a right triangle, we talked about that there is the hypotenuse, which is the longest side, the side across from the 90-degree angle, and then there's an opposite side and an adjacent side, and we learned how to tell the difference between those two sides. Okay, so then you form your ratios. The sine is the opposite over the hypotenuse. Okay, remember I taught you that SOHCAHTOA thing? Okay, the cosine is the adjacent over the hypotenuse. Okay, tangent you can think of in a couple of ways. We talked about that it's the sine of the angle over the cosine of the angle. Okay, as far as the sides of a triangle, it's also defined as the opposite over the adjacent. Okay, and then cosecant of an angle, it's 1 over the sine of an angle. So all you have to do is go and flip the sign. So instead of opposite over hypotenuse, it's hypotenuse over opposite. And then secant of an angle, it's 1 over the cosine of the angle. So all you have to do is go and flip the cosine. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. And then finally, cotangent is 1 over the tangent of the angle. Okay, so you just have to flip the tangent. Instead of opposite over adjacent, it's adjacent over opposite. Okay, so this is what we talked about in section 4.1. Okay, so this is how we're going to get our trigonometric functions for the angles on the unit circle. Like I said, we already have the nice unit circle built with the corresponding right triangles, okay? So let's start out with pi over 6, okay? In doing this for the 4 angles, I am going to concentrate on sine and cosine because the remaining 4 trig functions you can get once you have sine and cosine, okay? So for right now, let's concentrate on establishing the sine and the cosine for each of these angles, okay? So let's take a look at pi over 6, which is 30 degrees, okay? So if we go back to our unit circle, okay, here is 30 degrees, okay? And when we were doing this, on page 4, we established the coordinates. If you draw a line from the origin to this point, you draw a 30-degree angle, you hit a point on the unit circle, which is right here, point A, and we worked on page 4 to establish the coordinates of that point. Okay, so that was the work we previously did. We constructed a 30, 60, 90-degree triangle to come up with those coordinates. Okay, so here's your 30-degree angle. You have your right triangle that you have built. Okay, so this is, a 30, 60, 90-degree triangle, and we use that relationship to get the sides of the triangle. Okay, so first thing we're asked to do is find the sine of 30 degrees. Okay, we're just going to use this triangle. Okay, sine is the opposite over the hypotenuse. Okay, we are doing this for 30 degrees. You've got to pay attention here because there's 3 angles in the triangle. There's a 30-degree angle, a 60-degree angle, a 90-degree angle. You're computing the sine of 30 degrees. So that's the angle you're looking at, okay? You want to find the opposite side. The side opposite the 30-degree angle, you need to go straight across. Here's your opposite side. It has length 1/2, okay? And then you need to divide that by the length of the hypotenuse. The length of the hypotenuse is 1, okay? So this is going to be 1/2 over 1, okay, which is 1/2 or 0.5. There's the sine of 30 degrees, okay? That's what this is. Let me actually write this out. We just computed the sine of pi over 6, which is equal to, let me just erase this so I can write it a little better here, okay? We just computed the sine of pi over 6, which is the same thing as the sine of 30 degrees, okay? We took the opposite side length and divided it by the length of the hypotenuse, okay? And there's the value, 1/2, okay? That's it, okay? So we could do the same thing for the cosine of pi over 6. If you were looking for the cosine of pi over 6, which is the same as the cosine of 30 degrees, go back to that triangle, okay? We need to do the adjacent side over the hypotenuse, okay? Remember, we know the hypotenuse is 1. That's the side across from the right angle, okay? We already established that the side that has length 1/2 is the opposite side, so the other side has to be the adjacent side, okay? It has length of the square root of 3 over 2, okay? So you're going to take the length of the adjacent, divide by the length of the hypotenuse, and boom, there's your cosine, okay? All right, so this is going to be the square root of 3 over 2 divided by 1. It's going to give you the square root of 3 over 2, okay? There's your cosine, okay? All right, let's go ahead and continue. Like I said, I'll talk more about the other 4 trig functions after we get through the sine and cosine. Let's jump over to 5 pi over 6, which is 150 degrees, okay? So let's go pay a visit. Here's the point on the unit circle for 5 pi over 6, or 150 degrees, okay? And again, we are going to start off trying to compute the sine of 5 pi over 6, which is the same thing as the sine of 150 degrees, okay? So when you're doing this, okay, we worked on page 4 to establish the coordinates on the unit circle at this angle, and these are the coordinates we came up with. So to do that, we constructed this red triangle, okay? It's a 30, 60, 90-degree triangle. So one thing you might notice is there's not a 150-degree angle in that triangle, okay? And that's okay, okay? How we got this, remember how we came up with this particular triangle, okay? We said that if we drew 150 degrees in standard position, we would start along the positive x-axis and we would rotate counterclockwise until we got to 150 degrees, okay? And then we drew down to the x-axis okay? And we said to get to the x-axis, you had to go 30 more degrees, okay? So this 30-degree angle, we call that a reference angle. I'm going to put a theta on it. This is going to be our reference angle. This is not 150 degrees itself, but we're using that 30-degree reference angle, and that's what we use to draw our triangle so that we can get the coordinates for 5 pi over 6, or 150 degrees, okay? So in the same fashion, okay, we use this triangle to get the coordinates on the unit circle. We're going to use this triangle for 150 degrees to get the trig functions, the values of the trig functions, okay? So we will be using this triangle even though it's not 150 degrees in the triangle, okay? Okay, so you would do it the same way, okay? If we're starting with the sine, we're going to have to do the opposite over the hypotenuse, okay? Now, something you need to keep in mind, okay? We are working with lengths of triangles, okay? So usually the length of something is a positive number, but remember, we just took a look at pi over 6, okay? And we're dealing with a different angle now. 5 pi over 6 and pi over 6 are not the same angle, okay? There's a different amount of rotation, okay? What is going to distinguish these guys? Okay, well, remember what's different other than the rotation is the quadrant that they lie in, okay? Pi over 6 is in quadrant 1, 5 pi over 6 is in quadrant 2. So to distinguish these things as far as the trig functions are concerned, you're going to have to take your quadrant into account. So since 5 pi over 6 is in quadrant 2, the x-coordinate is negative and the y-coordinate is positive, okay? So even though we're dealing with like the length of a triangle, okay, you can think of this distance right here, the square root of 3 over 2, as being negative because the x values are negative in quadrant 2, okay? And then this distance of the triangle, the 1/2, it's positive because in quadrant 2, the y values are positive, okay? So you are going to have to take sine into account when you're doing your trig functions, okay? So let's go ahead and compute the sine of this angle, okay? So you would use your 30-degree reference angle, okay? And you're going to do the opposite side, so go straight across from that angle, okay? You're going to hit 1/2, and then you're going to divide it by the length of the hypotenuse, which is 1, okay? So this is going to give us, this is going to be 1/2 over 1, you get 1/2 again, okay? All right, let's go and do the cosine of 5 pi over 6, which is the cosine of 150 degrees, okay? So this time you're going to go back to your triangle. You're going to do the adjacent over the hypotenuse, okay? So using this reference angle, we just found the opposite side. We know the hypotenuse is a measure of 1, so that means this distance is the adjacent side, okay? And again, we're in quadrant 2, so you need to think of this x distance as being negative. Okay, so the adjacent side, we're going to write negative square root of 3 over 2. Okay, and then divide by the hypotenuse, which is 1. Okay, so if we write this down, this is going to be the negative square root of 3 over 2 over 1. So the value of the cosine here is going to be negative square root of 3 over 2. Okay, all right, so now let's look at 7 pi over 6. Okay, so 7 pi over 6 is down here. It's the gray triangle in quadrant 3, okay? 7 pi over 6 is 210 degrees. 210 degrees, that's bigger than all the angles summed up in a triangle, okay? So again, there's no way you could have a triangle with 210 degrees, okay? So that's why you're having to use reference angles to do this, okay? Again, when we drew 210 degrees, we started in standard position, and we rotated all the way around until here, okay? So then we took the difference between this angle and the x-axis, the nearest way to the x-axis. So 210 minus 180 gave us the 30-degree reference angle, okay? So we will be using this 30-degree angle as our reference angle in this gray triangle to compute the trigonometric functions for 210 degrees or 7 pi over 6, okay? So if you want the sine of this guy, if you want the sine, you're just going to do the length of the opposite over the length of the hypotenuse, okay? Again, you've got to keep it in mind that this angle is in quadrant 3, okay? So the x values and the y values are negative, okay? So when you look at this distance of 1/2, you really need to think of it as a negative length because the y values are negative there. And you, like we've already discussed, because that horizontal side shares, it's the same side shared with the red triangle. You need to think of that x distance as a negative distance. Okay, so both x and y are negative here. So to get the sine, you would take this reference angle, go across, straight across, hit your opposite side, that's negative 1/2, and then divide by the length of the hypotenuse, which is 1. Okay, so here, if I go back over here, the sine of 7 pi over 6, which is the sine of 210 degrees, this is going to be negative 1/2 over 1. So the answer here will be negative 1/2. Okay, do the same thing for your cosine. Okay, so we just need to go and get the adjacent over the hypotenuse. Okay, so here, if you do the adjacent side is going to be the negative square root of 3 over 2. Okay, you're going to divide that by the length of the hypotenuse. Okay, so we're going to get this. So negative square root of 3 over 2 over 1. So we'll get negative square root of 3 over 2. Okay, there's your cosine. And then we finally reach the last angle. Okay, 11 pi over 6 or 330 degrees. We're going to go ahead and start by computing the sine of this angle. Okay, so go over to your unit circle. Okay, here is 11 pi over 6. Okay, we're in the 4th quadrant, so your x coordinate needs to be positive and your y coordinate needs to be negative. Okay, so when you're looking at this triangle, again, you're going to have a 30-degree reference angle because when you drew in that angle that was 330 degrees, you started at the positive x-axis, you rotated all the way around to here. Okay, you had 30 degrees left to get back to the x-axis. Okay, so your reference angle is going to be 30 degrees. Okay, so you need to go ahead for the sine. Okay, you need to go and hit the opposite side. Okay, this is negative 1/2 because y values are negative here. Okay, divide by the length of the hypotenuse, which is 1. Okay, by the way, the hypotenuse will always be positive. Okay, so if we do this, this is going to be negative 1/2 over 1, which is negative 1/2. And now let's go get the cosine. So the cosine of 11 pi over 6, which is the cosine of 330 degrees. Okay, go back over here. Okay, here's your reference angle. Okay, we need the length of the adjacent side, which is right here. Okay, that's going to be the square root of 3 over 2. Okay, it's positive because we have positive x values in the 4th quadrant. Okay, divide by the length of the hypotenuse, which is 1. And so we will get the square root of 3 over 2 over 1. So the square root of 3 over 2. Okay. All right. So we've got sine and cosine established for each of these angles. Okay. Now watch this. This is fascinating. Okay. I'm going to go back to each of these angles. We're going to notice something major. Okay. Let's start with pi over 6. Okay. What's the sine? 1/2. Okay. Look at the coordinates. Pi over 6. Here's the coordinates for pi over 6. That y coordinate is the sine of pi over 6, or 30 degrees. If you go back, look at the cosine. The cosine is the square root of 3 over 2. Okay. Go back and look at the circle. The x coordinate of that point, there's the cosine. Okay. This is a thing. Okay. Look at 5 pi over 6. Okay. 5 pi over 6. The sine is 1/2. Go back to the circle. Look at 5 pi over 6. Look at the coordinates. The y coordinate is the sine. The cosine is the negative square root of 3 over 2. Go back to the circle. The x coordinate is the cosine. Okay, I'm telling you it's a thing. Okay, look at 7 pi over 6. Guess what the sine is going to be? The sine is the y coordinate. This is the sine of 7 pi over 6. Look, okay, Sine of 7 pi over 6, negative 1/2. Yes. Here's the cosine. Okay, cosine of 7 pi over 6, negative square root of 3 over 2. There it is. Okay, check it one more time for the last triangle. I'm not lying to you. Okay, so if you look at 11 pi over 6 and you look at the coordinates of the unit circle, the y coordinate, the sine, it should be negative 1/2. There it is. Okay, here's the sine of 11 pi over 6. Here's the cosine of 11 pi over 6. Okay, there it is. Positive square root of 3 over 2. Okay, this is major. Okay, what this is saying, okay, if you go to the unit circle, okay, if you go to the unit circle and you pick an angle and you look at the point on the unit circle corresponding to that angle, the x coordinate is the cosine of that angle and the y coordinate is the sine of that angle. That is major. Okay, so I'm going to rewrite this. You can rewrite the ordered pair as the x coordinate is the cosine of the angle and the y coordinate is the sine of the angle. Okay, one more time. This is major, 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 major. Okay, if you go to the unit circle and you're looking at a specific angle, and then you look at the point on the unit circle corresponding to that angle, the x coordinate of the point is the cosine of that angle, and the y coordinate of that point is the sine of that angle. Huge, huge. Okay, so you don't have to build a right triangle every time you try to do this. You just have to know, hey, look at the point on the unit circle. The x coordinate is the cosine and the y coordinate is the sine. Boom, I'm done. And then, well, how do I get the 4 remaining trig functions? Well, what do you do? Okay, let's go back to pi over 6. Okay, if I'm looking at pi over 6, okay, I've got the sine and the cosine. Okay, to get the tangent, all you have to do is do the sine divided by the cosine. Okay, so if you did that, the sine is 1/2 divided by the cosine, which is the square root of 3 over 2. Okay, if you're dividing fractions, you leave the first fraction alone, change to multiplication, flip the second fraction, okay, and then multiply. Okay, your 2's will cancel. You'll get 1 over the square root of 3. Rationalize it. Okay, you're going to get that the tangent of pi over 6, or the tangent of 30 degrees, is the square root of 3 over 3. Okay, if you went to your right triangle, okay, if you went back to the unit circle and you looked at this triangle for 30 degrees, okay, if you computed the tangent, so you did the opposite over the adjacent, okay, you would get the same thing, because it would be, opposite side would be 1/2 over the adjacent, which is the square root of 3 over 2. Okay, so it's all making sense. Okay, so if you kept going, okay, if you wanted to get the cosecant, okay, you just get it from the sine. Cosecant's 1 over the sine. Okay, so go back to your sine and flip it. Instead of 1 over 2, you're going to get 2 over 1. So it's going to be 2. Okay, keep going. If you want the secant, it's going to be 1 over the cosine. Go and flip the cosine. Okay, instead of the square root of 3 over 2, it's going to be 2 over the square root of 3. Okay, and then you rationalize it. So this is going to be 2 square root of 3 over 3. Okay, and then last one. Okay, if you want the cotangent, you flip the tangent. Okay, so go up here. Okay, it's the tangent is the square root of 3 over 3. We just need to flip that. So it will flip to be 3 over the square root of 3. Okay, rationalize it. This is going to be 3 square root of 3 over 3, and then the 3's cancel. So the cotangent of 30 degrees, or the cotangent of pi over 6, is the square root of 3. Done. Okay, and you would do the same thing for the remaining 3 angles on here. Okay, you would just compute these guys, the tangent, the cosecant, the secant, and the cotangent, using your sines and cosines. Okay, You're going to get very similar answers to what you did for pi over 6, okay, but the sign might be different, okay, because remember, I'll do one more here. If you're looking at the tangent, of 5 pi over 6 in this column, okay, you would take the sine and then divide it by the cosine. The cosine's negative here, okay? So you're going to get a similar type of answer because you're doing 1/2 times 2 over the negative square root of 3, and then the 2's cancel, okay? You would get negative 1 over the square root of 3, rationalize it, okay? You're going to end up with the negative square root of 3 over 3, okay? So you're going to get very similar answers, but the signs might be different, okay? I will complete this chart because, it's pretty self-explanatory if you've seen it once. And then, if you want to try it, you can go back and check yourself, okay? But the big thing you should be taking away from this, okay, is that now that we have these coordinates on the unit circle, okay, you can get the values of all the 6 trigonometric functions, okay, from those coordinates, okay? You don't have to make a right triangle, okay? If you take an angle, if you have a particular angle that you're trying to compute the 6 trig functions for, okay, look at its coordinates on the unit circle, okay? The x coordinate is the cosine of the angle, and the y coordinate is the sine of that angle. And then once you have sine and cosine, you can get the 4 remaining trig functions, okay? Make sure you take the sine into account, okay, based on what quadrant you're in.